Hi everyone, welcome back to Random Accessible Maths. I'm Dr. Ramchurn, and in today's lesson we'll be taking a look at Bidmas, also known as BODMAS, or in the United States, PEMDAS. So, what is Bidmas? All Bidmas is an agreed upon way that mathematicians have decided this will be the order of operations. And it's an acronym, so let's start with the first letter B, which stands for brackets. The I stands for indices. And division, multiplication, addition, subtraction. So, the other acronym, BODMAS, has two possible meanings. Sometimes the O is referred to as order. That's just another word that we learned about indices or index. So we have power, we have order. Sometimes it's referred to as other, as in other functions which later on in maths, such as the trigonometric functions or logarithm functions, if you do those would come after the brackets. Now in PEMDAS, the P stands for parentheses. Parentheses is just another word for brackets. It's used more in English rather than in maths. And the E stands for exponent, or an exponential, another word for power. And the rest of it, MDAS. You can see that the M and the D have swapped, but that's not an issue because, as we'll see in a moment, multiplication and division are essentially the same thing. So, let's take a look at why the order of operations is the way it is. So, starting from the bottom, addition and subtraction are inverses of each other. Therefore, they have the same priority. They can be done in any order. So let's take a look at an example of that. If we have 5 plus 7 take away 3, we can choose which order we want to do this in. We don't have to do the addition first. So let's start by doing 5 plus 7, which is 12, and then take away the 3, which results in 9. If, however, we decided to do the subtraction first, we would then do the 7 take away the 3 to give 4, and then the 5 add the 4 would give the 9. So we can see in both instances the addition and subtraction give the same result no matter what order we pick. Let's take a look at one more example now. So in this example, we have 1 take away 2, take away 4, add 9. Now let's choose an order of operations. So if we pick the minus first, we can do 1 take away 2 to give -1, and then take away 4 and then add 9, and then we can choose to do the -1 take away 4, which is -5, add the 9, which finally results in an answer of 4. We could also then do a different operation order. If we do the addition first, we'll be doing -4 plus 9. So don't forget that this is a -4, not just a 4. So -4 plus 9, that could give us 1 take away 2 plus 5. And then we could do the -2 add the 5 to give us 3. And then 1 plus 3 gives us the 4. So again, the order in this case doesn't matter. Addition and subtraction are inverses of each other. Therefore, they can be done in either order. Okay, so moving on from addition and subtraction, now we have multiplication. Well, multiplication is simply repeated addition. So if we have something such as 3 plus 4 times 5, the multiplication is actually a repeated series of additions. So this 4 times 5 is actually 3 plus 4 added it to itself 5 times in a row. So now we can see what the result should be. It's 3 plus 4 plus 4 plus 4 plus 4 plus 4, which results in 23. So therefore, if we were to prioritize the multiplication first, we'll get the correct result of 23. If we wanted to do the 3 plus the 4 first, before the multiplication by 5, we would have to put brackets around the 3 plus 4, which would give us a different result, 7 multiplied by 5. Let's take a look at another example. So, in this next example, we can see there's a multiplication and a division. Now, in the same way that addition and subtraction are opposites, and therefore can be done in either order, well, multiplication and division are opposites, or inverses of each other, so they can be done in either order. So, with this operation, we can either pick the 5 times 4 to do first, in which case we would get 20 divided by 2, resulting in 10, or we could do the division first, which is 4 divided by 2, to give 5 multiplied by 2, which also results in 10. So the D and the M in Bidmas can be reversed. Now, moving on to this example, we have indices involved. We have 3 to the power of 4. If we remember what the index means, this means 3 multiplied by itself 4 times in a row. So writing in full, we have 2 multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3. If we were to work out this result, we would have the final result of 162. And if we prioritize 3 to the power of 4, which is 81, this will also give the agreed upon result of 162. If you wanted to do the multiplication between 2 and 3 first, again, you would have to put brackets. So we would have something like this, 2 multiplied by 3, and then the bracket separates the 3 from the 4. So now we would have 6 to the power of 4, which is a different result from 162. So therefore, these are not equivalent. So, if you've watched my previous video on powers, we should also be able to remember that roots, square roots, cube roots, and so on, are just another version of powers. You can think of them as inverse powers. So they have the same priority, they are part of the I in indices. So if we have a power written like this, the square root of 49, we need to remember that this is also 49 to the power of 1/2. So therefore, this is the priority. So following on from this then, if square roots are powers, then what about if we have something like this? The square root of 49 to the power of 3. Well, if we change this into powers with the square roots, we should remember, using our laws of indices, that this could be written as 49 to the power of 3 raised to the power of 1/2, which we can then swap the order of multiplication using our laws of indices, and instead do the square root first, and then cube the result, in which case we would result with 7 cubed, which we know is 343. So, going back to the order of operations Bidmas, it might be more beneficial to write it like this. We have the B first, brackets, indices, and then because division and multiplication are the same priority, we could write the D and the M in the same column to show that they could be done in either order. And the same with the addition and subtraction, the A and the S could be written like this. So this way of writing Bidmas seems more appropriate based on the fact that division and multiplication can be done in either order, and addition and subtraction. So, If you've benefited from this video, please make sure you share it with someone who you also think would benefit. Give it a like, comment and subscribe, and I hope to see you in the next video. Take care.